I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Barrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. In this video we're going to be taking a look at setting up the forward end of the boat and doing a mock trial fit of everything that we've done so far. So I've made frames 1, 2 and 3 so far, which we've got here. We've beveled those on the CNC machine. We've cut all the notches for all the timbers that are going to go through that. I've also laminated and then beveled and notched the stem as well. So we've got the whole forward end of the boat. And what I want to do now is set that up on a section of the Strongback. And that's going to allow me to just have a look at how everything that I've done to date is actually going to work. So see if the timbers are going to land nicely and the bevels are going to be correct and things like that before I roll out this system throughout the rest of the boat. And hopefully it's all going to work. So what we need to do first is to get all of these parts prepped and ready to go into the Strongback system. So the frames have got to have legs put on them, and we've got to pick up the waterline 1 mark so that we can set them at the correct height and level them. The same thing with the stem. This stem mould that we use to form the lamination gets cut down, and then we're going to fix the stem lamination to that mould, and that's going to help us to align it within our Strongback system. I've also been working on a CNC cut Strongback, so I'll be cutting that in this video and we'll be seeing how that goes together as we assemble the whole forward end of the boat. So let's get cracking on that. We'll do the frames first, we'll get the legs put on those, so I'll show you how that process works. Okay, so we return the frame to the frame construction board. We use the dowels to reposition it within this whole assembly, and we only need a couple of dowels in this. I've just put 2 into the deck beam here and then 2 down into the keel section. So that's going to allow me to position the legs onto this frame so that we can install it in the Strongback. So the first thing that we need is some legs for this. And the legs are just ripped from MDF or standard particle board, whatever you decide to use for your constructional components. So I've got a stack of legs here. Okay, and then the legs get aligned with this Strongback leg 1 dowel. So that's going to give me the outer edge of the Strongback legs, which on the wider frames is going to align with the inner faces of the Strongback longitudinals. And on frame 1 and the stem, those are slightly further in because things just get a bit narrower. So if you've got an older version of the plans, then this Strongback leg was designed to align just with a standard 10mm dowel. On this newer MFT version of the table, I've added in this extra 20mm dog hole, which is going to allow me to use one of these super dogs and just get a slightly more positive and fitted alignment on those. So I'm going to put a dog in each of the 20mm dog holes. And because they've got this expanding section on the bottom of the dogs, it just gives a really positive fit and alignment in that hole. It's a nice solid edge to work to. Okay, so these legs want to be fitted to the bulkhead side of every frame that has a bulkhead on it. If you remember, these bulkheads are dry fitted to these frames at the moment, and they'll get separated back out when we install the stringers and things further down the line. So all of our legs get fitted onto the side of a bulkhead. So that's the reason I've got frame one with the bulkhead side up at the moment. And then we push the leg outwards so that it butts up against the inside face of those dogs, or dowels if you're using the dowels, and that creates our vertical plane for our leg, and it also creates the correct spacing as well. Now, one other thing we want to do is to add in some packers for the various parts of the frame to make the frame vertical in this plane. So obviously our deck beam here is lower than our bulkhead by a thickness of 12mm. So a little offcut of the stock that I've used for the bulkhead is going to help us to do that. So I'm just going to cut a piece that will be wide enough to span those two legs. Okay, so I can tuck that packer underneath these legs, and what that's going to do is then bring those parallel to the frame face, which is what we want. That's where we want them to be. And then height wise, we've got so we've got our waterline 1 mark here, but then we've also got the top of our strongback, and our strongback's 250mm high, so we want to be just a little bit less than that really. So we've got a good amount of leg that goes down into the strongback, but we don't want it to be too high so that we can't get down and meet waterline 1. So I'm just going to measure from that strongback leg, and I'm going to come down around about 230mm. That's going to give me a little bit of wiggle room there. I want to be pressed up against those two dogs, and then I can screw this into place. Okay, so once we got the legs fixed to the frame, we then have got to just transpose the various marks onto the legs and onto the frame for all these sort of key positions that we might want with this. And the most important one of those is waterline 1. That's going to set the height of our frames within our whole assembly. So we put 2 more dogs into the holes along the waterline 1 mark. And that then allows me to position a straight edge along that line and then transpose that line through onto my frame legs. Now, the other way to do this, if you aren't using the MFT table and you've just got these engraved lines on it, is to just use a square and transpose that line up and onto the leg. So the way that I would recommend doing that is to put your square up against the line like that and then rotate that in so that you can get it to touch right up against your line. You can use the top corner of the square there just to verify that that line's correct. So in this instance, I'm just using that to double check my line against what I've transposed from the dog, and it looks pretty good. So we'll do that for the center line as well, same procedure. Okay, so that's frame one, ready to go into our Strongback assembly. We can now lift this up off the board, remove those dowels, and you can see we've got the reference for waterline 1 for our height and a center line, which is just a really helpful line to have anywhere you can have it on the boat, certainly on every frame. So that one's ready to go in. Let's get the other two done as well. Okay, so there's the stem back on the lamination jig that we used to form its shape. You can see it's got a really nice fit to that back edge where I remachined the back profile of that stem, took out any spring back that we have, so we've got a really nice fit there. So the mould has got these lines on it which would be used to transpose onto the stem, and you would use them to guide the landing of your various components if you are cutting these in manually. The topside battens are done just by an equal spacing, and obviously the shear clamp runs to the top of the stem, and there's a trim line for that as well, which you can see. And it's nice that the CNC cut part of this is lined up perfectly with that, so that's a good indication. Same as with the chine top rail line that you can see there. And then the trim line at the far end as well. So what I'm going to do is I'm just going to transpose these frame lines through to the stem, and they're just going to be a handy reference to have when we locate all of this. So that's what I need to do here. The other thing that happens is that this jig gets cut down now. So we cut this along the line of frame 1 once I've marked those frame landings on there. And we use just this lower portion of the stem mould to position all of this within our Strongback setup. And you can see we've got that waterline 1 mark down on it there, which is going to help us get it at the correct height. Now, as you can see, our finished stem is a little bit wider than the mould that we've got, and I want something, just a little sort of cradle or something that's going to just position that and align the two in the middle. So I'm just going to measure the difference that we've got there. We've got about 10 mil, so I'll make a little 5 mil packer that's going to go either side, and a little tab, I think, that just spaces the two of those so we can get a good positive fixture of the two together. Okay, so that is the stem fixed into its alignment system within the boat. So that's going to fit onto the front rung of our Strongback and get it placed. So that is all of our parts ready to go in. What we need next is a Strongback, so let's get cutting the parts for that. Okay, so that is our CNC cut Strongback. So we've got our longitudinals here that form the two main beams down the full length of the boat. So we've got 4 of those that join together to form the full length of the Strongback beams, and they use this same dovetail system that you will have seen in other jigs that I've done previously. I've done an engraving just to mark the stations on there. It's not really essential, but seeing as it was on the machine, it made sense just to do it, and obviously I had to put the Temptress name on the on the central one as well, wherever that is. So these are our rungs, and you'll see we've got a little tenon system here, so we'll get that put together and you can see how it works. And these are locking pegs as well for the tenons, so these are going to go through and just bind everything into place. Also got some squaring frames, so these are going to help us to get the whole assembly squared up. They're just a temporary thing that will drop in place. So that's what we're looking at. It's a little bit less efficient than the original manually done Strongback. Now, I originally designed these to be 1200mm internal faces, so these can be ripped really efficiently from sections of particle board. Obviously the inclusion of the tenon takes them just a little bit over that, which means that we actually get really quite inefficient with material, which is a little bit of a shame, but it's a kind of payoff. Little bit more material usage versus probably quite a lot of time saved, and certainly a lot of induced accuracy. We're going to remove the potential for errors within positioning each of these stations, I hope. So let's get it set up. I'll show you how it goes together. Okay, so it locates with a pretty simple CNC cut tenon system, and these are going to go through these two little notches here. Now I'm just going to put a little chamfer on the edge of them just to ease them into that that slot. Just because these are quite a tight fit and I want a nice positive alignment. So that's just going to help me to get that started. Okay, so once that's located, we've got a little locking pin that's going to help us just to tie that tenon in and stop any movement. Now, when I'm going to put this together, I will actually epoxy all of this as well. We want some nice size fillets on the inside of this setup just to make sure that nothing moves, because once we start hanging quite heavy boat frames on it and we start pulling in timbers, there's going to be a lot of force on this assembly, and it wants to be really tough. So this is going to get us our initial accuracy, then we'll beef it up a little bit with some epoxy fillets. So we'll just knock that tenon in as well. And you see that's got a slight taper on it there just to help it go into that hole. Okay, so that is the forward end assembled. This is just half of the longitudinal, so you can see how long this whole assembly is going to be, and it's only just going to fit in my workshop. We'll see that a bit further down the line. I'm going to have to do a bit of decorating downstairs to get all this in. So this is the forward end. Now when it comes to setting this up, there are two primary things to focus on really. The levelness of the top of the setup, levelness, is that a word? Isn't that critical. If your floor is miles out, then you probably want to do a little bit of packing on some of the corners if you're on a very uneven floor surface. But generally as a whole, the top plane of this isn't too critical to be level. That's the reason that we use waterline 1 as a laser level plane throughout the boat, is that we can eradicate any curvature of the strongback in that way. The two things that are really quite critical is that the longitudinal beams are dead straight. So what we'll do is we'll ping a string line down those and we'll pull it tight, and we'll check that there's no curvature, because this has got the ability to curve in that way. That's a very critical thing, and also that it's all square. So obviously the rungs need to be perpendicular to the edges. Now I've just knocked up a couple of little framing tools for this, just a very simple thing that's got a slot in it underneath that is going to help us to square that up, and they're just going to fit over this longitudinal and down onto the rung. And that's just going to help to make sure that everything's square and rigid. Now these can just pop off and on. As I mentioned, we're actually going to glue this to the floor when I set up the final boat. I'm going to temporarily screw it at the moment, but these can just be put in place as you're working on each individual rung, and make sure that it's held perfectly perpendicular. Okay, so temporary measure, I've just clamped a straight edge down the side of this because I don't want to mess around with string lines. We'll take a look at that when we set this up full length, because obviously twice the size of this, we need a dead straight line down the whole thing. So string line is probably the only way really to do that, but this will do me for now. I just got some of these little blocks left over from cutting the stem that I used to secure these down to the CNC. So I'm going to temporarily screw this in place, and it'll all be fixed nice and tight, and then we can put some bits in it, see how they look. Okay, so we'll start with the laser. Now that's got to be approximately 75mm above the top of this. It's not really critical, to be honest, it's just a rough reference guide. So we'll play around and see where I can put this. Then we can start getting some bits in. So I'm going to start with frame 3. And I'm just going to square the lines around the legs. So we've got a waterline 1 mark on every side of the leg. Then we can drop this in. Okay, so frame one, the Strongback legs come in, as we saw when we attach them to the frame. So they're not going to align in the edge of the Strongback like these are. So I'm just going to measure what that is. That is 420. And I'm going to put a little mark on this rung so I know where to position the frame in that plane. That looks pretty good, doesn't it? That is really nice. So that's what we're looking for. We've got a laser right through the middle of that line. It's amazing how accurate you can be, actually. Probably the width of the laser's maybe 2 millimeters, 1.5 millimeters. And if you can get that pencil line dead center on it, you can get a really accurate height, which is nice. We've got a nice match up in here, the bevel angle on our keel and stem cutouts. Frame 2 matches the contour of the stem. That's nice. See that fitment into there, look. Looks really good. The only thing I can see initially that looks a little bit awry is this landing of frame 1. So it looks like we're a little bit low. Our bevel angle seems correct because we've got the same gap either side, but we're a little bit shy here. This should really be marrying up straight into this bevel, and something's not quite right there. So I'm just going to have to do some checks to get to the bottom of why that is, because we're at the correct height on the stem. So stem's the correct height, stem top is in line with that trim line, chine line looks good, so the stem would be indicating that it's at the correct height, as is frame 1 with its legs correct either side on the laser. It could be something to do with the framing this way. If this is just pushing this frame back a little bit, thinking about it, I wonder if that trim line there is the face of the frame rather than the face of the gusset, and so it's pushed that back slightly. If that's got to come forward by that much, that's going to probably get us somewhere around about right. I'll just have a look in the CAD model and double check that. I can also put a level on this and see how vertical this is. I haven't done that yet. On any of these frames, actually, they should be perfectly vertical. So I'll do a couple of checks. We'll do a little bit of investigation, see if we can just get that tiny little error corrected. Okay, so a little bit more investigation. Just whacked a level on these. I've got these pretty well spot on. They move a bit when I touch them, actually. But frames 1 and 2, nice and level, nice and vertical, which is good. And what I've done is I've just taken out the jig for frame 1, and I've now got that vertical. But what I did have was, it was further back like I suspected, so it was originally here. So you see that line was just in the face of the gusset there. Now I've brought that forward, so at that it was a little bit tipped back. the level was reading tipped back slightly, so I've brought that forward. You can actually just hear that locate beautifully in there. It's quite satisfying indeed. And when that mark just lines up there with the face of frame 1, we are both perfectly vertical on there, but we're also running straight into this bevel, and that's exactly what we want to see there. Perfect transition of that frame into the bevel of the stem, which is really nice. So what I'm going to do is probably just trim this out slightly accordingly, just to cut around that that gusset there. Okay, we've got a timber. I'm going to put this into place, see what we start to get for the landings at various points. So we'll chuck this in where the chine top rail is going to go. So this should just start to give me a bit of an initial indication as to how timbers are going to land on these bevels. This is quite a strange feeling. I don't know how long you've been following the channel. Let me know in the comments below how long you've been a subscriber of the channel. But the last time I did this was on missile, and I made a video about it. It's a really old video that probably be a bit embarrassing actually watching it back. The last time I cut a set of chines into a stem like this was probably 10 years ago, I think, on a new build boat anyway. So that's quite a strange thing to be revisiting, and things have definitely changed here since the last time I did this. This is a substantially different process now to the way I did missile. Anyway, let's get a tenon saw. We'll start cutting some angles here, and we'll try and get this chine pulled in a little bit closer to where it actually wants to lie. Okay, so I'm just going to do an initial rough cut. Now my angle, the outside of my chine is around about correct. So this is the landing that I want to match. And the good thing with having these CNC cut is that I can use this to drive the angle of the chine, whereas doing this the traditional way, you'd basically have to kind of balance the two and bring them in steadily at the same time. So what I'm going to do is I'm going to just roughly copy that angle as best I can at the moment with my tenon saw. And I'm going to make a cut at that. That's not bad. That's certainly better than I did it 10 years ago. Tell you what, that's almost passable actually. Okay, I'm pretty pleased with that. I've just roughly cut these. These are just scrap pieces of timber, so it's not worth me messing around trimming them too much, but I've got the landing fairly close on that, and the same on a topside batten. Topside battens are a little bit thin, but it's just what I had on the rack for now. I just really want to see the landing of this, so that is working out really nicely. I would expect there to be a little bit of trim room needed there maybe, but that's pretty damn good. I'm not complaining at that. Obviously we've got a straight run off on the end of the chine there, because what's going to happen realistically is that this will continue on round as it pulls into the next frame, and that will ever so slightly affect the landing up forward there. You can see the landing there. Look, if I lean on it, it's actually going to close into more like that, but got a beautiful fair curve to that, which is nice. It's landing well in there. The sort of edge set on it looks good, and same with the top side batten coming in there. Really chuffed with that. I don't think I could ask for much more. That looks good. That's quite satisfying. I know I'm a bit of a boat nerd, but I like that. That's good. Now obviously this isn't really representative of how a plank's going to lay, because they're going to be done in opposing 45s, so this isn't going to quite land, and I've planked this wide isn't suitable and stuff, but you can just see, you know, the angle of that stem there that's landing on is just spot on. And each landing of the frame, yeah, I don't think I'm going to need to do any fairing on that framing. That is a massive time saver, and that time saving is going to follow on all the way throughout planking the bottom of the hull. There's going to be less fairing to do with that, because we'll start with a fairer framing, so then we'll get fairer planking, and that'll work right through to the finishing on the top sides. If we can get all that level of fairness throughout the whole boat, I'm going to be really pleased with that. Nice, I like that. That has made me happy. Okay, so I think we can call that a successful setup. I'm really pleased with how this has all worked. Everything seems to be landing really nicely, like I would have hoped. Yeah, I'm happy with that, really pleased. What's next? Well, this kind of proves the process. This means that the beveling's working really well. Everything that I've done on the frames and the stem is working a treat. So I can now proceed to roll that out through the rest of the frames with confidence. I can certainly refine the process with which I'm machining those frames. Definitely made improvements with each step, and I think that process is going to get quicker as I go through them as well. So we'll have a good bash on a batch of frames. I think that's going to be the next thing to do. We've got what have I got? 10 more to do, I think. 13, yeah, 10 more to do, and they vary slightly. We've got some that have got full bulkheads on, and we've got some with open topped, where we've got the cockpit and the engine hatches, things like that. So a bit of variation there. As always, I want to say a massive thank you to everybody for supporting this series and this build, because I am trying to self-fund this and do it under my own steam, which is quite a difficult and challenging undertaking, but I'm hoping that I can make it work one way or another. So it's great to see some new people on board with Patreon. Thank you guys for signing up to that. Really appreciate the extra support there. And also to the sponsors as well that are helping me out with the materials for this build, because that is massively helping with the dent that it would otherwise be making in my pocket. So hope you've enjoyed this video, and let me know in the comments below what you think to the setup and the process. It's great reading through all the comments that I get from you guys. I really appreciate you dropping one below the video. So hope you enjoyed this, and I will catch you in the next one, where we'll have a bit of a marathon, I think, with making some more frames. So cheers guys, catch you in the next one.